Okay, I'd like to clear many things on the screen so you can see it clearly. Look at this. We have x1 and x2, and we have 1 and 1 here, and this is the exclusive for OR. So this one is positive class, this one is positive, oh sorry, uh, this one is negative class, this one is negative class, and for these two they are positive, and we have two lines here, that is from this one to and this one. And guys, we'll have another P1 and P2, and from P1 and P2, look at this. We have the negative one here, and we have the negative one here. This is the positive one, and we have a line here. Look at the direction of the positive decision. For this one is P1, this one is P1, this is in P2. So the direction that will be classified as the positive one is shown in the using the arrow, the direction of the arrow, and this one is same. Okay, for P3, this one is P1 and P2, and this perceptron is this perceptron is P3. Okay, so of course you can see that this is the normal OR operation, right? Right? Yes, because it's 1 1, it is positive, and the other one is here. This is negative, and this is negative, and we don't care this one, right? Because there is no point here. So this is same as the OR one. And how about this one? This is same as the OR. Sorry guys, it's not. It is the this is the AND one, not the OR one. Sorry. And this one is OR. So this one is OR, right? And this one, look at this, look at P2. P2 is the same line as the AND one, right? This one is the same line as the AND one, but the decision direction is different. It's on the opposite side. So from AND, this one will be NAND. Alright? And you already known the weight of AND and OR. You have already known the weight of this line. For the AND one, it is if your W is W0, W1, and W2. The AND one will be minus 1.511. This is one of the weight that can be used to classify the AND example, right? I hope that you still remember. And how about the OR one? The OR one is minus 0.5, 1, and 1, right? Okay, just only look at this, just only one x1 or x2, just only one x1 or x2, one of these, one of x1 and x2, okay, can be sum with W0 and is greater than 0. This is the OR, the weight of the OR. This is the weight of the AND. And how about the weight of the NAND? Of course, it will be same as the AND one, but it is the opposite direction. So it is 1.5 minus 1 and minus 1. Right? So I hope that you still remember that we have the weight like minus 1.5 plus x1 plus x2 is 0, right? This is W0, this is W1, that is 1, and W2 is 1. the opposite side of the weight is you can move everything to the other side of the equation. So it will be 1 plus 1.5 minus x1 and minus x2. So that is W0 is here, that is 1.5, W1 is minus 1, and W2 is minus 1. So this is the weight of the NAND. Okay, so now we've got all weights, and you can put all weights in your structure. This is x1 and x2, this is p1 and p2, and this is output. And this is p3, and this is output, and this is a weight. So your p1 is OR, right? P1 is OR, so your weight is here. So it is minus 0.5, 1, and 1. And for P2, it is NAND. So this one is 1.5 and minus 1 and minus 1, right? The weight of NAND. 1.5 minus 1 and minus 1. And the last one is AND. AND is minus 1.5 and 1 and 1. And this is the output. You can try to use these weights to work with to test that if you put the input of exclusive OR here, like 0 0 0 1 1 0 and 1 1. If you put these input vectors into, or if you feed this input vector in this class, and how can you classify the final output? Like if you put 1 and 1 here, so 1 and 1 times here will be 2, right? 2 and minus 0.5 is greater than 0, so this one is positive, so output is 1, right? And if you use if you put it here, it will be minus 1 and minus 1, so it is minus 2 plus 1.5 is minus 0.5, so it will be negative here. Okay, so the output is negative. So when you have 1 and 0, put it here. 1 0 times 1 and 1, it is 1 and 0, right? So it is 1 dot, the dot product is 1 plus minus 1.5, so the output is minus 0.5, that is less than 0, so the final output is negative class. Okay, so you can try it by yourself to check the output of all examples, and you will see that they are the result exactly of the exclusive OR. So guys, I hope that now you can know that what is the idea of the multi-layer perceptron. So if you have the space, like for example, if you have the 2D space and you have the positive class here and the negative class are here, so how can you classify the positive from the negative one? You may need the line here, you may need the line here, you need the line here, and you need the line here. And then put it together using the AND operation, right? So now you have 4 lines. It means that you need x1 and x2 here, and you need 4 perceptron and some sum the result together. Okay, so one perceptron is for each line. And all of them must be true. All of the output must be true here. Okay, so you will get the area, sorry. You will get just only one area that will be classified as the positive class. Okay, so I hope that you get the idea how can we use multi-layer perceptron to classify the examples. Okay, so in the next video clip, of course, we dedicate or we design this perceptron. We design the weight. We design the position because we know the what is where is positive and where is the negative area, right? So you can find the weight using the linear equation, right? But in some cases, no, sorry, in general cases, you need to train it. You need to automatically update the width. How can we train this multi-layer perceptron? I'll show you in the next video clip.